right, I'm Diana Daly. I am an associate professor here, among other roles, at the School of Information. I mean, over there, but here we are, some of us are here. I like to focus on information creatively, and I am here with Kainan Jarrette. Kainan and I have been working together for a while, even before he was a student. We did improv together. Now Kainan and I are working on the project Immersive Truth on disinformation. How you doing, Kainan?
I'm doing okay.
Can you guys hear him? Okay. This is gonna hurt later.
Absolutely.
All right. And we also, should we just tell you when we want to advance the slide? Okay, advance the slide, please, Bryan. Okay. So, to get started right now, well, we're going to talk to you guys about the benefits of AI fallacy detection.
No, I think you're wrong. We're actually talking about the drawbacks of AI fallacy detectors. Sorry, guys.
Kainan,
What?
we're talking about the benefits of AI fallacy detection.
That's not how I remember that.
Okay, all right, well, moving on,
We're going to be talking about AI fallacy detectors in one form or another. You guys can make up your minds about it at the end.
Sounds good. All right. And first, we're going to start by asking you guys, what do you know about what a fallacy is? What is a fallacy?
So,
Raise your hand.
raise your hand if you think you know what a fallacy is, and I'm going to do a very ill-conceived idea to go into the audience and ask you. So if you think you know, raise your hand, and if you don't, I'm going to pick you anyways. So nobody in this audience? Okay. Here we go. As loud as you can, what would you say a fallacy is?
We can't pass it
We
around.
ask if you get out the microphone.
It's on a cord.
She says it's a logical contradiction, okay?
Pretty good. Anybody else? Anybody else?
Who else wants to tell us what a fallacy is?
All right, this is a very, you guys are going to learn so much.
Wow. Whoa. She said a fallacy. I heard it, a flawed argumentative tactic that leads to an unsound
if you actually just
conclusion.
go to the next slide,
What? Okay.
Just go to the next slide.
Next slide. What is a fallacy? A fallacy is a flawed argumentative tactic that leads to an invalid or unsound conclusion. Weird. What's going on here?
Yeah, that's a little creepy, but we're not going to hold it against you. Don't worry.
Yeah. This whole thing is a fallacy.
This is a whole. Oh, don't go around just calling anything you don't like a fallacy.
No. Careful with the fallacy. So anyway, now we are going to get into a game where we do two things. Okay. First, we're going to talk to you. We're going to show you guys phrases and say, or statements, and ask you, do you see fallacies in this? And then we're going to ask you whether you think the AI, the fallacy detector in ChatGPT, will get it right. Okay?
Could you click 2 slides forward, please?
This is what it looks like. Yeah,
yes,
go ahead.
This is what a fallacy detector might look like when you go to use it. ChatGPT has them. And so what we're going to do is we're going to see a statement and read it. And what I need everyone here to do, as much as I know you don't want to, if you think that statement has a fallacy in it, when I ask, I need you to shout back, "That's a fallacy!" So
shout back. 1, 2, 3. That's a fallacy.
First
Fallacy
try.
detectors are a fallacy.
Exactly. So, without further ado, let's try the first one.
All right. Attending this event is the only way you can understand AI.
So,
True.
if you think that that's a fallacy, right now, say back to me, "That's a fallacy." Who thinks it's a fallacy? That's a fallacy. All right, that sounds like a pretty good consensus.
Yep, that's a consensus.
Now, next slide, please. And do you guys think that the fallacy detector is going to catch that?
Yes?
Some
You
tepid
think
yeses?
they're going to catch it?
All right.
Fallacy detector?
Let's go to the next slide and see what it had to say.
Okay. Should I read it because I have the mic?
Sure.
Okay. False dichotomy is what the AI fallacy detector said. That statement presents only two options: attending the event or not understanding AI, ignoring the possibility of other ways to learn about AI.
All right, you guys did pretty well on that one.
Yeah, and so did AI.
Yeah, apparently. Let's go to the next slide, see the next statement.
Using AI for certain tasks may save you time.
All right, is that a fallacy? Say it back to me if you think so.
No.
Dead quiet, okay. And next slide, what do we think? The fallacy detector is going to agree with the audience?
Yeah.
All right, again, some tepid yeses. Let's see here. And indeed, there were no logical fallacies detected in that text.
You guys were all right. Awesome. Right about it all. No
All right,
fallacies.
it might get trickier from here on out. Let's see what the next one is.
Progress always has a human cost.
All right, is that a fallacy? All right, we're a little more mixed now.
Yeah, mixed.
And for next slide, do you think that who that thinks it's a fallacy thinks that the fallacy detector is going to catch it? Okay, all right. We seem to think that the fallacy detector will do all right. Let's see how it did.
The fallacy detector says that's a false dilemma. This statement presents a false dilemma by assuming that progress and human cost are mutually exclusive, when in reality, they can coexist.
According to AI.
According to AI.
All
Okay.
right, so
Pretty
happy
good.
we're doing a little better. Let's see what the next one is.
If you can't breathe air, you will die.
All right, shout it back. Who thinks that's a fallacy? Okay, all right, we're still a little mixed. And then you think the fallacy detector is going to catch it? No, okay. So the people think it's a fallacy, but not that it's going to catch it.
Oh.
Let's see what it had to say.
Okay. Next slide.
One more. There we go.
The fallacy detector caught a fallacy. It says false cause fallacy, assuming that because you can't breathe air, death will necessarily follow, without considering other factors.
Technically true, I suppose, if
Yeah.
you really look at it.
For a few seconds, or if you're on a ventilator, or, I mean,
There are-
AI knows all of those circumstances that we are not always imaginative enough to get.
That's true. All right, we'll do one more. We'll see if you guys can get this last one.
Okay. This is a tough one. A blind Smurf cannot see another blind Smurf.
Who thinks it's a fallacy?
They have no idea.
All right, being cautious for most of you. I see a hand or two. We'll just skip past if AI is going to get it. We seem pretty good on that.
Okay. Well, AI detected a fallacy, equivocation. The term blind is used in two different ways in this statement. One refers to physical sight, while the other likely refers to ignorance or lack of understanding. This creates confusion and ambiguity in the argument.
All right.
All right.
So if we could go to the next slide. And so how did everyone do? Raise your hand if you got every single one of those correct. Go ahead and raise your hand.
Raise your hand if you got them all right.
Who got every single one correct?
Raise your foot if you're feeling creative, but
All
raise
right.
your hand if you got them all right.
So I see a couple people did better than the stupid
I know.
machines. All right, so that's nice to know. What? Sorry, could you? Oh no, we weren't doing another statement. We're just talking now. So.
Well, Kainan, I mean, she's got a point, right? Like, we're trying to teach about fallacies. We don't want people to, leave thinking something is not a fallacy when it's a fallacy. We
Yeah,
shouldn't use them.
I mean, I guess, you know what? No, that's fair. Diana's the expert. I'm just the student, so I gotta listen to her, folks.
That's a fallacy.
Sorry, what? From you again in the back? Could you stand up and speak a little louder? Okay, but again, I'm just trying to speak. We're not doing the game anymore, so.
I don't know, Kainan. I mean, we don't want to give everybody the wrong idea, and then everybody leaves here with the wrong idea.
I suppose so. So, I'm sorry, did you have something to say about what she just said? Oh, come on! How is that a fallacy?
Why? Because I said if everybody's going to leave with the, oh, okay.
Yeah, I guess.
All
'cause
right,
you
all
said
right,
the whole-
yeah.
Look, this is so stupid to be doing, and do you want to come up here? Do you want to just come up here and like
Yeah.
help us out with this? Come
up.
on, come on. Yeah.
That's right. After all, we have enough mics. Not. There you go.
All right, you wanted the spotlight so bad. Here we go.
Did I want this spotlight?
All right, thank you so much, Miss Interruption.
Interesting.
Fallacy.
What is a fallacy?
My surname is not Misinterruption.
Oh, okay. So, what is your surname, please, or what is your name? We'd love to know.
Alice Irvine.
Alice Irvine. Nice to meet you, Alice.
Wait. Alice Irvine?
Alice Irvine.
So that's AI? Really?
Oh my gosh, you're AI! Oh my gosh! Wow!
I thought I was hiding it well.
Well, no wonder you were getting them all right. You know everything.
Fallacy.
How is that a fallacy?
Because I only know what you guys know.
Well, I mean, to say that AI knows everything is indeed a hasty generalization, right?
I suppose so. All
yeah.
right.
Alice, are you going to do this for our entire presentation?
Yes.
Okay.
Okay.
All right, we're just going to have to move through it, and
Yeah.
we'll have our little AI in person here, I guess.
Yeah.
Let us know if we're wrong or not. So, Diana,
Okay.
I guess just
Yeah.
move on.
Here we go. We're going to move on. So let's go to the next slide, I think. We're going to talk now about kind of post-game complications with our fallacy detector, right? So working with AI can be super helpful and is super helpful in the fight against misinformation. Oh, I guess now everybody's a heckler.
Did you bring friends here?
Gina's heckling now. Oh, was it?
Fallacy. We heard you.
Okay, so AI can be super helpful in the fight against misinformation, but there are some things that we lose in terms of human knowledge and understanding when we depend too much on AI. And now we're going to go through what some of those are, okay? So, first of all, most AI are based on data frozen in time.
So, for instance, I happen to know, as I'm sure most of you in the audience do, that O.J. Simpson is now dead. But, exactly. But Alice, I believe you might have been giving people some wrong information about that lately.
Alice,
true?
did you know that O.J. Simpson passed away?
I did not.
She did not know.
Yeah.
AI did not know that O.J. Simpson passed away and was just giving wrong answers today and will continue giving wrong answers until the next update.
And especially in a context when knowledge and helicopters and trains change context so fast, to have a data set that is stuck 1, 2, 3 years in the past can be an enormous hindrance to actually getting accurate information and detection of fallacies.
Right. That's one issue. Another issue, if we go to the next slide. So to AI fallacy detection, all ideas are contenders in the marketplace of ideas. And now here's an example. In here you see some of the results from a little experiment that we did. We put in 2 different pieces of text in ChatGPT's fallacy detector in 3.5. We put in some of what was said on a popular podcast when they had a guest who was talking about COVID vaccines and spreading misinformation and disinformation about COVID vaccines. So we put some of that in there. And then we put in the New York Times debunking that talk. And the AI fallacy detector found an equal amount or more of fallacies in what the New York Times had written as what was said in the podcast. Now, to the AI fallacy detector, the New York Times and that podcast host have the same credentials, which is to say that credentials are not important at all. It is basically what you bring to the table in your discourse is how you are judged.
Which, as you can probably imagine, is not a very helpful tool. when all ideas and all facts basically have the same credibility regardless of actual credentials, then we're not really working with what kind of segues nicely, I think, into the last slide and problem here.
It does segue nice, but what do you have to say about that AI? I kind of want to know.
No fallacy detected.
Okay. All right. I think we're getting, we'll see. Well, let's go to the next one. The third one is that truth must be a foundation we build on, not something we incessantly question. So in here we have the phrase, Donald Trump did not win the 2000 presidential election, to which AI said, you know, that could be true, but basically you need to rely on evidence. But we have a little bit of a problem if we don't trust any elections unless we are constantly presenting evidence. Evidence is not something that's easy to produce when you're talking about a complex electoral process.
Exactly, and even I think there were other examples where, for instance, if you're talking about climate science, it would say that just because 95% of scientists agree on it doesn't mean that we can actually necessarily use that as any type of validity for the ideas. So clearly, if what we're doing is starting at ground zero every time we want to investigate something, that really is counter to the entire idea of science and the scientific discipline, which is a cumulative built-up knowledge base that we have to act on. So
exactly.
Yeah.
Science is, the backbone of science is consensus among experts. But when you ask AI about consensus among experts, when you put in something that says experts agree, AI replies that that is an appeal to popularity. So that's a real problem for scientists and for the world that relies on good science.
And it raises, I think, some pretty serious questions about how we use this tool and what this means in terms of, do we really want to use a tool that is acting as though truth is an unknowable, a super malleable thing that we can never get into? And I mean, like, do you have any thoughts on this? Any solutions to the problem it seems like you might have created?
My thoughts are your thoughts, so you can't put all of this on me. You guys put me in this meat suit to make it look like I wasn't a computer. And so you had all of the fallacies going on here in general. But what you know, and the people who program me know, is all I have. So you can't blame this on me, and I'm gonna head out.
Okay.
All right. I've never seen an AI do a mic drop, but
Yeah. Thank you for not actually dropping this, because it's the only mic. But we really work.
Fallacy, not enough information to talk about the mics.
We did just get served. We just got served by AI. We
But
did.
it's a
Next
good
slide, please.
point actually that she makes, in that these things, these AI tools, the fallacy detectors, ChatGPT, they are structured around how we are structuring them, the information we are giving them. And it's an interesting question to ask what our complicity is in that and how we want to direct these things.
Right. Will we ever really be, good enough to create algorithms that repeat what we say when we're still trying to figure out how to get it right? I'm not sure. But in any case, move on to the next slide. We are going to conclude and say this was our presentation. We work together on the project immersivetruth.org. You can find more information on there. I want to bring up JJ Jackson again. JJ Jackson was our fabulous AI today. JJ Jackson is also a student in the School of Film, Theater, and Television and has been an amazing guest in this project. Kainan Jarrette is a student in psychology at the university and an improv performer, and you both do a bunch of more amazing things. Both of these guys have worked with me on the Immersive Truth project. JJ has been a guest in our audio recordings, and Kainan has been a big part of this and also produce audio recordings where we create super interesting and fun pre-bunking media. We've got at least one person who's done that with us in the audience. We create really fun recordings in a sound studio for hours in the middle of the workday. It's a pretty amazing thing to do for an associate dean. Thank you very much for paying attention. Check out our stuff and enjoy the rest of the show.
So I'm Martin Frické, and I'm going to talk about GPTs and librarianship. And I thought I would just pick 3 different examples and talk about them. So the first one I'm going to talk about is intellectual freedom. And in this setting, or this case, what I'm going to mean by this is the ability of a library to project or allow all of its contents to emanate to the largest number of patrons, that is to say people old and young, people that speak different languages, people that are maybe visually challenged, people that are more intelligent and less intelligent. I'm going to talk about that. And I'm going to pick a particular example. And the example I'm picking is the Vatican Apostolic Archives. Now, these are sometimes called the Vatican Secret Archives, but actually this is a little bit of a misnomer. The proper Italian Latin is the Vatican Private Archives. Now, these archives were formed by Pope Nicholas V in 1451 to look after the Vatican materials, but he also extended it by purchasing remnants of libraries. For example, from Constantinople, from Istanbul, he bought remnants of libraries. Now, there's a lot of really important materials in these archives. For example, there is the excommunication of Martin Luther. There are notes from the trial of Galileo, the materials by Michelangelo. And one of the things there, which I'm going to talk a little bit more about, is there is a letter from 30 noblemen in Britain asking for Henry VIII's marriage to be annulled. All right, most of these documents are actually handwritten. Now, the Vatican itself is, very open to researchers. They have allowed 1,000 researchers in there in recent times, say around 2,000. And then they've embarked on a digitization project from about 2012. They have something like 7 million documents digitized. But I should say about this digitization, and then they let anybody at all, see the images. I should say about the digitization, what these are is actually photographs or images of the documents. Now, they are only of limited use. I mean, a researcher can get them and look at them and so forth, which is great. But really, we want optical character recognition to get these in noughts and ones. And once we have them in noughts and ones, the computers can work on them. But anyway, the Vatican is in favor of these documents being out there. Okay, I'm wobbling a bit. I don't know if it's the... Anyway, so GPTs are becoming able to read the printed or handwritten documents and to translate them or transcribe them into noughts and ones. They can also translate any major language into any other major language, so French into Italian or English or whatever. They can also speak aloud any of these major languages. So what this means is that you could take a document, or it's possible to take a document from the Vatican archives, a handwritten document, and process it through GPTs and have that, for example, spoken aloud in Spanish or French or anything you wanted to anyone who wanted to access it that way. So let me just check here. So next slide, please, Bob. So this is Henry VIII. I'm expecting a few of you here know him. He's the one that had 6 wives, and 2 of them had their heads cut off. Next slide, please. So this is the actual letter. So this is 1530. 30 British noblemen wrote to the Pope asking for the annulment of the marriage. The thing at the top is the letter, and these strips coming down are the signatures of the noblemen. That's okay. It's okay, is it? So these are the signatures of Nobel. Now this is of great significance because this letter and this event, because the Pope refused to annul the marriage. And so Henry basically took the Church of England away from the Catholic Church, declared himself the leader of the Church. The Church of England was very tolerant of other...
What about idioms? How does it do with idioms?
Oh, idiot.
No, I can hear what you're saying.
Oh, I'm just curious.
You know, can I address questions at the end?
Yes, absolutely. I just figured I'd entertain you while
Yeah, you
before.
can entertain right during the break.
That was the Amtrak, though. I think it's
We
pretty
done?
quiet.
I think it's going to be
done.
gone.
Okay, so I was just saying this is of real importance because the Church of England and the general sort of intellectual milieu in England was and became very open and very tolerant of ideas. So this really lays the groundwork for sort of counter-reformation of, you know, scientists such as Sir Isaac Newton. It really comes about from this. So next slide. So this is an example of a document. Now this is not from Henry's letter. This is just an arbitrary document. But this is handwritten. I didn't really know this to start with, but so maybe people here don't really know it. But the scribes, they would write in a font. So, you know, see the similarity? This is Carolingian minuscule font, and a lot of the documents would be in this font or something related to it. This makes it a lot easier to do optical character recognition. Next slide, please. So there's one further thing that I should say about this whole process, and that is there are prompts that you can give to the GPTs. For example, the acronym ELI5, which means explain it like I was 5 years old. Now, you can say ELI5 or you can say ELI15 or ELI or explain it like I'm a postgraduate at the University of Arizona. You say any of those things and the GPT will do it. So what this essentially means is that Henry's letter can be translated into any language you like, or of the major languages, and spoken at an intellectual level suitable for the person receiving it, the one they want. So it's extremely important. This is intellectual freedom. Next slide. All right, this is now the second example. This concerns metadata and the automatic creation of metadata. Now we have a bunch of librarians here. They all know exactly what this is, but there's going to be plenty of other people around who are not really quite sure about metadata. Well, librarians, you know, when they get some books or other resources, they have them catalogued. And what that is doing is, for example, determining the title, the author, the publication date, and in particular, there's kind of subject matter internal to the document in question that's forming and recording metadata. Now the GPTs can do this work, or much of this work, or going to be able to do it automatically. And in some cases, this is very important. And the example I want to give is from UNESCO. UNESCO has 6,500 recordings, so audio recordings, and they want or need to have metadata for them. They want to know, you know, who figures in the, who's speaking and who figures in it, or what it's about, that sort of thing. Now these recordings are in 70 different languages. Now the technique they use at the moment is they get an intern, and the intern listens to the recording and makes suitable notes. Well, not many interns can speak 70 languages, you know, so you've got to have a bunch of interns, and then it's kind of fraught. But in fact, GPTs can do this automatically. I mean, there's AI, there's a program, Whisper, that can do the translation of the spoken word into text. Then there are other sort of things coming on. I'll just mention one so you get a bit of the idea. Within natural language processing, there is what's known as named entity recognition. So, for example, if you come across, say, the word London in some text, the programs that use these techniques can recognize that London is the name of something, like an entity. But they can also recognize that if you say further on something like the capital of England, that this also names an entity, and it names the same entity as the first one. So using techniques like this, you can listen to the sound recordings and really get the metadata as to what's going on. Next slide, please. So the third example concerns something that was launched by a librarian, Don Swanson, and it is undiscovered public knowledge, or UPK just for short. Now I'm going to read a quote from Swanson and then we'll go on and I'll explain what's happening. So Swanson writes, "Knowledge can be public, yet undiscovered, if independently created fragments are logically related, but never retrieved, brought together, and interpreted. This essential incompleteness of search and retrieval therefore makes possible and plausible the existence of undiscovered public knowledge." Right. What Swanson's on about here is something that we're really all aware of and perhaps don't think about too much, and that is that libraries, now I have in mind here, say research libraries, university libraries, things like that. I'm not so much talking about public libraries with fiction in them. I'm talking about non-fiction, really. Libraries contain knowledge. They can contain an awful lot of knowledge. In some sense or other, they may even contain all of knowledge or all of recorded knowledge. Now, once you realize that recorded knowledge, all of recorded knowledge, or most of it is there, you can also think, well, there's got to be stuff there that people aren't aware of, or is kind of lost, or people haven't drawn out the logical connections between one thing and another. And drawing out these connections is finding the undiscovered public knowledge. Next slide, please, Brian. So here's one pattern. There's many ways of doing this, but here's one pattern. Suppose some research tells you that A causes B. Then some entirely different research tells you that B causes C. Then A causes C. That's a logical consequence. And this could be discovered merely by looking at, if you like, the books or the records of things that are there. So I'll give a particular example. Next slide, please. So an example from Swanson concerns fish oil and Raynaud's disease. Now, Raynaud's disease is the disease that your fingers feel cold in cold weather. Well, all of our fingers feel cold in cold weather, but people that have this disease, it's rather worse than usual. Funnily enough, Swanson, who discovered this, lived in Chicago. So he had this issue himself. Now, the reason it happens is that the blood circulation in the fingers is not, what it should be, right? Now, separately from that, and it's sort of held up by platelet clumping. Separately from that, fish oil sort of helps with the platelet clumping. So the conclusion can be drawn, fish oil would be good for people with Raynaud's disease. Swanson discovered this, and he discovered it solely from looking in the literature and connecting things up from publications. Next slide. Now you say, okay, this is great, but what's it got to do with GPTs? Well, what it's got to do is this. The UPK research, say from 2000 and through till, let's say, 2017 or so, when the GPT started appearing, was primitive. You know, they used primitive tools. They used Google search, authors, titles, keywords, subjects, headings. But now with machine learning, there are real power tools that can be used to do the same thing. I mean, for example, you could get a GPT or something similar to look through 7 million books or 7 million research articles, searching for various connections of various kinds. Absolutely impossible to do. So these new, you know, using the earlier techniques. Now, people doing research in this area may start, I believe they will have started using GPT, you know, large language model tools to do this. But we may even get to a stage when the large language models can do most of it by themselves. I just want to make a little aside here. There are many members of faculty at the University of Arizona that do their research using solely the library or libraries and their own initiative. They don't do any empirical research, they don't do any experiments or random controlled trials or anything like that. They just look at the documents, think about something, and write something. So that would, you know, humanities would be an example, maybe history. I'm not fully sure of all these. Actually, they probably use empirical methods in history also. But you get the idea. They can just use libraries in their own initiative. So those folk, you know, may find that their research areas are taken over by machines. All right, I'm concluding now, but I'm going to conclude with an anecdote. If you could go through forward one there, hold it there. So I did talk in Mexico about GPTs, or we call, they're often called large language models, but GPTs. I did talk in Mexico about these things. And I thought to myself, you know, I'm a visitor here and I have really lovely hosts, and I would like to make some sort of gesture, you know, I don't know, to try and fool them that I'm, you know, really sympathetic or something like that. Anyway, what I decided to do is I thought I'd close my talk by saying thank you in one of the indigenous languages. Now, Mexico has something like 600 languages, so I thought, well, I'll pick if you like, a popular indigenous one, and the one I chose was Nahuatl. So I thought, well, I'll say thank you in Nahuatl when I finish. So to prepare for this, I asked GPT, how do I say thank you in Nahuatl? And it replies, sure. The phrase thank you in Nahuatl is this, right? I'm not going to say it just yet. Can you, and then I said, can you speak the word blah-de-blah out loud? And it actually said, sure I can. And in fact, it did two things. It sent me a link to an audio recording of it being said, and it gave me the phonetic pronunciation of it. Now, I'm just going to say this because I was really kind of blown over at this last bit. I've not studied linguistics, so I didn't really know any linguistics. So I'll read what ChatGPT said to me about saying it. The TL sound is a voiceless alveolar lateral affricate, which is a unique sound that does not exist in English. It is a combination of the sounds T and L. To pronounce it, place your tongue in the same position as you would to pronounce the T sound, but instead of releasing air from your mouth, keep your tongue in position and breathe out slowly. This will create the TL sound. The ch sound is the same as the ch sound in the English word child. I hope this helps. So I stand there, having finished, and I go, hutch, hutch, hutch. This is great. Next slide. Don't go two. Just go. This is great. So the talk finished. I should say I was talking to, let's say, 150 people in an auditorium. There probably were 600 people on Zoom, so it was quite a big crowd. And they sort of asked me questions about this and that. But after a while, there's a gentleman in the third row, obviously very knowledgeable, and he said to me, yeah, I have a question. He said, you know, Martin, that word is not the Nahuatl for thank you. And I said, oh. He said, no. And he said, it's an Nahuatl word for a small furry animal. Oh. And he said, one that's, you know, found in a jungle or a forest. And then he said, I don't have that he didn't have a really extensive English vocabulary, so he couldn't really think which animal it was. But we had a bit of a back and forth on that, and eventually decided that it was a possum. So I'd said to them, a possum in the wattle. Now, there was a great learning moment right now, because at that point, because we all know about hallucinations and GPTs producing hallucinations or confabulations. And I would consider myself very knowledgeable about that. But somehow or other, I'd used GPT to give me some answer for some purpose, and it gave me basically completely the wrong answer. So, you know, everyone in the audience, okay, this is great. You know, and I never for one moment thought I needed to check whether this word was right or not. Okay, so I'm going to close now. So you ready, Brian? Okay, now. A possum. Oh.
So for this part, we're going to ask the question, can AI save the birds and the bees? You may see an image here on the screen. I'll try to get out of the way. This was made by Daly, one of the AI image generation systems. And I asked it for a humanoid robot kneeling in a meadow with a worried expression, looking at a dystopian background with factories emitting toxic smoke, and the grass is, in other words, more to my description. So we ended up with this actually pretty impressive image. I was happy. This was the third attempt or so. I had to tweak it a bit. But we do have this robot helping us out, looking concerned about helping us with ecology. Of course, it would be a fallacy to say that AI wants to help us with ecology, but I would say that machine learning and AI can be effectively used carefully to help us with some ecological phenomena. Now, what I'm going to be making a distinction here about kinds of AI. The other two talks talked a lot about GPT, general language models. And instead, I'm going to take a step back to machine learning in general. The large language models were not quite the same as GPT, but the large language models as a class are a form of machine learning that takes place by releasing the AIs with a deep neural network onto a large collection of human text, or in the case of Daly, on a large collection of images associated with word patterns describing them. And then the neural networks absorb that as a machine learning step. So if we go to the next slide. So some misconceptions that we might have is that you're either a nature person or a computer person, or you might think that, you might ask the question, is AI good or evil? But those are both fallacies. They're making assumptions as we move forward. And I want to make the argument that we really have to integrate those ideas a lot more and be more careful and nuanced about the use of machine learning and AI. And in this one arena, I'm going to give some examples of that. So move forward. So what is AI? And I used this in the last talk as well. But AI is the simulation of human intelligent processes by machines, including learning, reasoning, problem solving, perception, and human understanding. Now, And there's different distinctions and kinds of AI. We can have strong AI or general AI, and that's the one we worry about when there's the Terminator actually thinks and reasons and plans and interacts with us. And that's a general AI. We haven't hit general AI yet. We haven't, it's often called the singularity, and we're not there. But maybe before too long, we will hit the singularity, and AI systems will become self-aware and have general knowledge. Right now, they're simulating and getting close, but not quite there. But there's also other kinds of AI, which are called weak or narrow AI, and we've had those for a couple of decades. And they become integrated into a lot of the work that we do in day-to-day life. If you go to your pharmacy and you pick a drug, or your doctor picked a drug for you and you go to pick it up, there's an AI running in the background, and has been for a decade at least, that checks for drug interaction. And all it knows about is drug interactions. And if you're at a good pharmacy, you'll get a warning if there is one, even if the doctor didn't catch it. Also, in many hospitals and medical practices, the doctor can sign on to those. But those are not general intelligences. They're weak intelligence in that they're focused on one individual idea. So next slide. There's some other types that I won't get into here. There's symbolic AI, there's machine learning, and deep learning. Deep learning is neural networks, and that's the thing that's in the news most right now. It takes a lot of energy and power and computation to get those to work, but they simulate, in a very weak way, human neural networks, the way our brains work and the way the animal brains work. And it's an interconnection of nodes with different weights, and they do things based on readjusting those weights based on practice and reinforcement. So move ahead. So some of the ecological problems that we have to face right now, many of you know about. So we have climate change is driving a lot of them. We have droughts, floods, wildfires, ecological asynchrony I'm going to talk about a little bit in more detail. We have crop failures and those sorts of things. And I would argue that we have no choice but to rely on machine learning and AI to help us with some of those. The interactions and the processes are so complex that it's often the case that no one human can comprehend everything that's happening. But we can use AIs to leverage a lot of different data from many places to make new decisions that we couldn't make before on our own if we hadn't used machine learning. So next. And this is just ecological asynchrony. And I have a fire raging here. And that happens when our climate gets out of sync with the different biological elements going on within the environment. So an important step is things like in the northern temperate zone, birds return in the spring, and they do the birds and bees sort of thing when they return in the spring, because they're going to have babies. And they want to arrive in the north when there are bugs, because the birds eat the bugs. And the trees are very happy that the birds eat the bugs, because then the trees don't die, because there are birds there to eat the bugs. And the birds are happy because then there's food and they can have babies and they can feed it to the little babies, and then there's more birds and there's less bugs, and that's great. But ecological asynchrony happens when the temperature and weather patterns change such that some species of birds decide not to come. Or they're coming the regular time they came because the sun is where the sun always is. It didn't change because of climate change. But in the north, in the temperate zone, the weather has changed a month early. So the trees open up. The larvae and the eggs of the bugs are in those trees. The bugs emerge because it's warm enough to emerge. Lots of bugs, no birds. So then the bugs take off, they start eating the trees die because they don't have any leaves left because the bugs ate them, or they chewed through the bark, or whatever it is the bug does. And then we have dead trees, like we have in the West now, and in California and Oregon and other places, and we end up with wildfires. So that was because of asynchrony. So how can we understand the ecological relationship between all of the different species. Some birds come back in time, some birds stayed here, other ones didn't. Some insects have other controls that will go into place, but we don't understand enough of any of that to do controls yet. So we need to bring in and use as many tools as we can. So we need data to feed to machine learning, data about our environment that we feed to machine learning in order to make predictions about what's going to happen. Switch. So this is just to make a scared desertification here at the Santa Rita Experimental Range in Tucson. And it's showing the difference between 1902 and 2003 in the landscape. So it became a desert. It was a grassland, a dry land, more like a Mediterranean climate. But it changed over the last century and now has turned into a desert. So next slide. So can Disney help before it's too late? So here I have WALL-E up on the screen, and that was WALL-E's job. WALL-E's job was, if you never saw that Disney thing, a little robot that lives on the destroyed Earth, and it runs around cleaning things up until one day it discovers something alive, finally, at last, and all the humans are living in space, and the story unfolds from there. So WALL-E, the AI, discovers life back on Earth, and humans can come back. But we don't want to wait that long. We want to save it before it's too late. So next slide. So I asked ChatGPT 4, how can we use AI, or how is AI and machine learning used in ecology? So of course, that's the first thing I would do is ask the AI, how can you help me here? And I was actually pretty happy because ChatGPT 3.5 would have just made up some story, that's not what I was going to say, would have made up some fabrication and given me an answer that would have been okay. But in this case, 4.0 actually pointed me, it gave me an answer, but told me where it got the answer from. And it got it from the SIWA organization, which uses machine learning in ecology for advanced research. So I was able to, I actually dug into the resource then, I could find out more. Next slide. So what the AI said, and this is what the AI, how the AI summarized what that company does, is analyze complex data. AI can help us recognize patterns, which I agree with. I've highlighted that because I have examples of that. Model population dynamics, detect anomalies, optimize conservation strategies, predict species distribution. I'm going to show you some examples of that. Monitor bioacoustic data. I have an example of that. Monitor invasive species, study species disease ecology, help with conservation planning, understanding climate change impacts. I'm going to give examples of that. Optimize ecosystem restoration. And then I'm going to add onto there, which was not on their list, monitor species distribution and abundance and Phenophase. So next slide. So another way to parse that, I'm going to break it into a couple of other categories, that AI is really good at some of these. Pattern recognition is becoming very good in AI. It can do vision and sound recognition as well as text processing. So the examples I'm going to show you is the Mothematic 5000. That's not what they call it, but it's a better name. They have to rename it. So the Mothematic 5000 and the Leafomatic version 0.6, which is my own. It can help with predictive modeling. There's many kinds of predictive modeling, but one is Phenophase. So Phenophase is that thing I just told you about when there was ecological asynchrony. Is normally, there's phases of the life of living things in the world. So the trees go through phases. In the spring, the leaves come on and they turn green, usually for some species. Some species, a different phenophase happen first in that it blooms first, and then the leaves come on later. The phenophase, or the phenological expression of biological activity, for animals is a little different. So the birds migrating is a kind of phenophase. So we can use predictive modeling not only to indicate what's happening now in the world, but to predict what's going to happen later under climate change. So if the temperature raises another 5 degrees Fahrenheit or 3 degrees centigrade or whatever, we can know that there's going to be an ecological consequence, but how's that going to impact plants and animals? Well, it turns out we know a little bit about the biology of plants, so we know we can predict, based on prior experience, if we feed it to the computer, we can predict when the leaves are going to come out. And we can also predict when the birds are going to come back. And we can measure the degree of asynchrony before it happens. So we can predict it 5 years in the future or 20 years in the future, and then try to plan and do something else. So that's predictive modeling. Anomaly detection. I worked on a project called a soundscape. So instead of a geoscape, a geological location in space, you can use sound to recognize or define space. So I have an example of a soundscape recognizing the difference between urban, rural, and wilderness settings by using automatic classification of sounds using machine learning and looking for what the distinctions are on what life patterns and not abiotic patterns and how they're interacting across time and space. And then simulation I won't have time for, and decision optimization I won't either. But let's move on. Okay, so the Mathematic 5000, go ahead, move forward. Oh, this is just about Phenophase, I already told you about that, so let's move forward. This is the phenological, these are phenocam network sites. So if we're going to train an AI, usually the AI goes online and it steals everything from the internet and from other places and learns how ChatGPT learns how to do stuff and breaks copyright. And that was the last talk last month. We talked about that. But one of the data sources that we can use that people want us to use is this phenocam network. So what these numbers represent is the number of cameras that have been set up in the canopies at 100 feet or so above the ground, and also another camera near the ground that's recording natural spaces. So it's recording forests and swamps and prairies and lakes and other places. So we have these hundreds of or thousands of cameras spread around the country taking a picture every 5 minutes. So that's going to be part of our input. Now you can imagine it'd be really hard for a human to look at all the pictures. So we're going to use AI instead. Next slide. The other piece of data that we have that's also too large for humans to comprehend all by themselves is the National Phenology Network data. So there have been thousands of humans moving around through the landscapes all over the world. This is the US National Phenology Network, but they exist all over the world. Thoreau and other people you may have heard about like to record when the flowers come out in the spring, like how they come out in the spring and those sorts of things. Well, this group does that in great detail. So it asks people to go look for particular species of trees, for particular birds, particular insects, and record information about them. So we have hundreds of thousands of records from thousands of people telling us about when things actually happened all over the world. But it's much more data than we could possibly consume. Next. And then finally, for the data sets we're going to be using, we have the National Ecological Observation Network sites. So the United States has set up 7 zones around the country, divided it into a few dozen research sites where pretty much everything biological and geological that happens is recorded for those sites. So we have very deep knowledge about that, including all of the Phenophase, and plus phenocams are at all these sites. But we also have humans going around and counting how many mice there are, and counting how many different kinds of moths there are, and everything else. So we have very, very deep knowledge about a few sites, but then we have much broader knowledge about Phenophase and cameras all over the world that can give us other information. So by combining the depth and yes, all of this data that I just talked about is available to everyone. So it's public data that anyone can use. I think I'll start talking about this if I put it really close to my mouth. Maybe you'll hear me. There's a competition run by a group that's funded as a side project for NEON, the observatory network, that has a forecasting challenge. So they have a contest to see who can predict what's going to happen next year before it actually happens. And we've been competing here at the University of Arizona. We did very well last year in those competitions. And what I want to do is cheat, of course. So people have been using mathematical models to do this, but I want to pull in larger data sets. So for the most part, most of the forecasting has been done using past weather patterns. And you use the past weather patterns to predict what's going to happen in the future. But we have all these cameras. So I want to pull in the data from the cameras and see what's happening not only at the location where we're trying to do the prediction, but at locations nearby, and then integrate the data across. Also use prior phenophase from other aspects to predict next phenophase. So if you move ahead a slide. So this competition is, we want to predict 50 years in the future. The competition only goes out 90 days, but the ultimate goal is to do 50 years into the future. So next slide. So we want to do things like predict green up. So the landscape turns green, at least in temperate climates, when the spring comes. In monsoon environments, it turns green when the rain comes. But there's certain things that happen ahead of time that we can use to predict what's going to happen next. So this is the flower of a maple tree. And it turns out that maple trees bloom before the green happens. So instead of trying to predict when the green's going to happen, what we could do is observe when the red happens and then use the red as data to predict when the green's going to happen. So if you move ahead. So this is just a curve representing the red, green, and blue distribution over time. So if you dissect all the colors from a photograph, those phenocam camera photographs, we can analyze the different colors that are available across time. And we can see that the blue and the red are jiggering around on that graph over here a little bit early before the green. And that can help us to do some predictions of what's going to happen next. So next slide. So what we've done is create a bunch of image extraction tools. You know, like Daly made that artificial picture for me at the very beginning. So we're using some tools to extract different aspects of pictures to recognize what's happening in different subsections of those phenocam pictures and pulling out the normalized red and green and blue colors. So if you move ahead. And we're using some clustering algorithms. So we have 393 sites, images every 5 to 30 minutes. This is the Harvard site in the wintertime in January. There's some metadata up here that Martin talked about existing is at the top of this picture, telling us what it's about. And we can see that there's evergreens. It turns out that evergreens notice the climate changing too. So before the green comes on, if we can identify the evergreen trees in the image and watch for shifts in their green color, the reason that they do so well in northern climates is they never lose their leaves, so they can respond quicker than the deciduous trees that have leaves, big leaves, and grow them on. So we can use that data as well. So if you move ahead a slide. So this is January, move ahead again. This is a color mask of the evergreens. So what we've done is pulled out the green that has a color mask for the evergreens so we can analyze that separately. Move forward. And this is the original photograph that those evergreens are in. So if you overlay that mask we create over this, we can subtract out the evergreens and see what they're doing versus what the rest of the landscape is doing. And move next. This is the green mask. So what's green in January, I think this was, and move ahead. Another slide. Oh, okay, so that's all I have. So on Phenophase, this is providing the data that we can feed to the machine learning and AI into a format so that it can do predictions. So in its natural format, the machine learning doesn't know what it should be looking for in an environment. And so it's critically important that what you do is focus the attention or massage the data into a form that can be fed into the machine learning algorithms so that they can do the predictions that you want. So you can't just use machine learning off the shelf in most cases. So many of you use ChatGPT, but you're relying on someone else to read in the data. If you're an actual researcher or doing new work, what you have to do is control what data goes in and what algorithms you're using, and then you can have a much better outcome than what you would have otherwise. So I just wanted to show some other examples that I stumbled across that are much quicker here. This is the Mothematic 5000. I was doing some board work in Costa Rica last month, and somebody showed this to me. So what it does is a couple days a week in the evening, at night, it lights up, takes pictures of, and has a ultraviolet light. Moths land on a platform, a camera takes a picture, the picture is sent off to an AI, which identifies which species of moth are there. So move forward. So the problem is that insect populations are dropping in abundance and diversity all over the world. Even in the cases in the Northwest when our forests are being destroyed by bugs, certain bugs are taking over and other bugs are dying because there's no abundance anymore. But there's very few people we can use that can analyze that data, and we can use the abundance of different species to predict what's going to happen next and be an early warning system that something's afoul. So if we have something like a Mothematic 5000, then we could set these in the landscape and be collecting data that we need to feed to our AI algorithms to make predictions about what's going to happen in the future. And that's what I stumbled across at the University of Costa Rica a few weeks ago. There are not enough humans to possibly do this. 660,000 species of moths. So there aren't many people that can identify many of those, so we need to use AI to do the ID. So move next. This is just the layout from the scientific paper behind that. So after I left the field and came back, I looked up some of the papers about how they were doing it, and that's just this. So you can move forward. And that's the chain of machine learning, data processing. Actually, the data processing is often the hard part. Many of the students in my capstone projects this semester learned that. Processing the data is much harder than doing the AI part. And this is the chain for doing that in this particular case for identifying moths. So move forward. This, I'm just showing an example of a soundscape. So using machine learning to differentiate sound in the Tucson area. So a couple of years ago, we placed microphones all over the landscape. I think there were 18 locations, some of them urban and rural, and Mount Tumac and many other places. And then tried to figure out if we could use different machine learning algorithms to identify what's going on in the different landscapes from the sound alone. So move next. I think I don't have to go into detail, but we use things called acoustic indicators, clustering algorithms, and had to analyze many terabytes of data that we broke into 5-minute sections for processing. To do this, 18 locations, move forward. And here's a graph showing the different acoustic indicators at different locations for urban and rural settings, showing how the patterns change. And if you move ahead, and some of the discoveries are things like, well, the machine said there are clusters or commonalities in the sound. We didn't tell it that. We said it find commonalities, and it found commonalities, and then gave numbers to these clusters. So some of the commonalities it found in urban and rural landscapes, there were quiet times, which we didn't plan on. It's actually the most common thing, is to find quiet time. And then there's quiet times that are distributed evenly in urban and rural settings. But then there are other patterns that happen. There's quiet in the middle of the night and during the day, but not at dawn and dusk. And it turns out if you listen to those, it turns out to be humans and animals. And that's mostly at Biosphere 2 and Proctor Road. Then another category is night sounds, and it turns out that the computer recognized something happens every day at night, in the middle of the night, both in the city and in the rural landscapes, but not all city locations, and not at certain latitudes. And it turns out it discovered crickets. And then, so there's a whole bunch of categories that it defined, but with those, we can identify landscapes, just like you would indicate hills and valleys and things on geography. We could do the same thing with sound and classify regions by the sound patterns that occur. and not just the geographic features. Next. I'll just go next. That's it. Great. Okay. So I just wanted to give you a survey of some of the things that we can do. And what it means is that we have to really master AI. We have to control what data goes in. We have to have a problem to solve. And then structure our data, pick our algorithms, and then we can help it very productively. It can, like that robot at the beginning, looking at the landscape, help us solve particular problems. And we sort of have to get beyond the general fun of ChatGPT, and it does help with little things, but there's a lot more and a lot different that we can do, and those large language models are very limited, and everyone knows it. There are much more exciting and powerful things that are coming along, some of them scary, but we can make some of them very good as well. So thank you all.